Hey everybody, this is Jace with RMUS, and I'm here with
William Pryor from Skycatch.
From Skycatch, and today we're going to be talking about the Skycatch and those solutions. So, in a simple explanation, what is Skycatch?
Sure. Well, thanks, Jace. Skycatch is a geospatial data solutions company. We've been around for about 10 years, and we combine robotics and next-gen automation with drone data analytics to provide comprehensive data solutions. We're used by some of the largest global mining and industrial companies to create accurate drone data, and we have a multi-component system which covers a capture, process, and analyze end-to-end solution for creating accurate drone data.
All right, so this is the Edge1. This is the heart of the system.
Yeah, that's right.
Tell us about this.
So Skycatch Edge1 is what we call an intelligent base station, and it's an end-to-end solution which covers the capture, process, and analyze components of a comprehensive drone data collection platform. So when we talk about capture, process, analyze, really what we're doing is we have tools that work in the field, both on the flight planning side. We work with some of the most popular drones like M300, Phantom 4 RTK.
Stuff that everyone's familiar with.
Exactly, yeah, we see a lot of those here at RMUS. And we offer flight planning for those drones, making it super easy to collect very accurate data very safely and have a very consistent output, right?
Sure.
So the way the Edge1 works, a surveyor or a drone pilot will take the Edge1 out into the field. Inside of the Edge1, we have a high-precision GPS as well as a very powerful GPU inside running our Skycatch photogrammetry software. So once we go out in the field, we're flying maybe a DJI drone, like again that M300, we love it, covers huge areas.
Right.
The Edge1 is broadcasting a correction solution to the drone, just like the DJI DRTK. The drone is flying around and taking photos with a very high precision, high accuracy GPS position for each photo. So once we've used the flight planner called Flight 1 to fly that drone, the drone will return from its mission with highly accurately geotagged photos. We load the photos here into Edge1, and we process those photos.
Right, so really the way I kind of think of this is, and you can correct me if I'm wrong, but I kind of think of this as the Skycatch solution is flight planning, your base station, and your processing, and analytics all in one package.
Yeah, that's exactly right. So, what Skycatch is trying to do is, we're doing for the drone data collection environment what DJI did with drones itself. When we started the company in 2013, you couldn't buy a drone; you had to build one.
Right.
Now, of course, you can come to a provider like RMUS, and buy an incredible piece of hardware that sort of does it all. We're assembling the components just like DJI did with motors, flight controller, and sensors. We're assembling the different steps into a single package that we provide to customers.
Well, something that's the other half of that, though, from experience, is something that's user-friendly. Being able to put it into a way that is accessible to just about anybody with a little bit of time, a little bit of effort, and not that much time and effort, to be honest. But putting it in a package that's accessible, that's easy to use, and again, is that all-in-one solution. It seems like that's kind of the secret sauce that everybody needs. Is I need something that gets me from beginning to end, and I can live there.
That's right.
If that makes sense.
Yeah, and consistency is the name of the game. We make it very, very easy to process data. It's not like learning some of the traditional software that's used for photogrammetry processing. And because we turn data around in the field, we take a workflow with a photogrammetry drone, like a Phantom 4 RTK, and it functions more like a laser scanner because the drone, the user goes out in the field, they use the device, and the device will output a point cloud on the spot.
Gotcha.
So let me show you what that looks like.
Yeah, let's take a look at some data and see what we can pull out of here.
So yeah, as I was saying, the name of the game is consistency. We've been doing this for about 10 years, and we've seen people make all kinds of mistakes on collecting drone data, whether it's a flight plan with not enough overlap, bad processing settings, or incorrect maybe coordinate system.
There's a list as long as your arm or longer for the mistakes that can be made when you're trying to generate that type of data.
Yeah, we can tell your experience in tech support.
Yeah, just a little bit.
So what we're going to do is actually cut away to the way that we control this Edge1 in our iPad tablet. It's a very simple interface. You'll notice there's a lot fewer bells and whistles going on here than your typical photogrammetry system.
Sure.
Part of the reason that is because we focus on high precision GPS. Since 2017, we have been advocating for the we've been creating, I should say, a method for no GCP data collection. When you're not reliant on GCPs, when you're not relying on putting markers down in the field, we can simplify this a lot because we have the accurate GPS data in here, and we can process that data and project it right into the coordinate system that you need.
Right. That's again coming back to that simplified workflow.
That's exactly right. So to show you, we can go in here and look at one of these example data sets look like. So right now I've got my iPad, it's communicating over Wi-Fi to the Edge1, and this is what a surveyor would be doing. Let's say they've just landed their drone, they've put the data into the Edge1, and they want to process that data.
Sure.
So this is an example that we actually took near our near our headquarters in California. I can look in. We have a 3D preview of the data that was created. We'll be told, the type of drone that was used, the processing time, the accuracy level. We have the ability to actually add checkpoints to verify the quality of this data. And then we have a number of different steps. We can adjust the processing quality, and we can create a number of different outputs like point clouds, OBJ files, or meshes, and of course, orthophotos as well.
Right. So that's going to give us the opportunity to, hey, we can do stuff here, but then we can also take that somewhere else.
Yeah, exactly. What we get once we process the data, is a preview. We can see, we can make sure that we don't have any huge gaps. We had enough overlap. We've reconstructed, all of the things that we want to see in the data set that we were sent out to do. I've done it. The worst thing to do is, capture data, and you leave the site, and you don't know if you got a good capture until all that data is processed.
Right, which is, again, this is another one of those pain points that we've seen about 1,000 times. I captured my data, I sent it into the cloud, whatever, up to a server somewhere, and 24 hours later, that didn't work.
Right, yeah, flatline. Right. And of course, a lot of our users are in very remote areas. We're talking about, we're deployed in Africa, we're deployed in above the Arctic Circle.
Sure.
We're deployed in, the very deep reaches of Australia.
Little bit resource scarce.
Absolutely,
is a way to put it.
And hard to get into and out of, right? So you really want to know that your data was good once you process that. So just as an example, here this is just a demo data set that we took. It's got about 50 photos, and we processed this on standard resolution, right? The total processing time was just 3 minutes, right? So
more or less, and again, basically on site.
Yeah, exactly. So the Edge1 has a large battery inside. This will log for up to 12 hours at a time. So we can create a GPS log or do GPS correction for 12 hours at a time, and it will process continuously for about 8 hours. So
gotcha.
We have surveyors who go out and use this device, and they'll do something like 12 jobs, in different parts of, let's say, a mine before they return back to the office. The data is processing the whole time they're out of the office, and they return to the office with the data completed.
Well, it's processing from the moment they landed the drone while they're driving to said office.
Yeah, that's exactly right. So it's a huge time saver. We save a few hours for each data set, depending on how much sort of manual handling you have of that data afterwards.
Sure.
So some of the capabilities that the data processing on the Edge1 has, we are able to select different processing qualities. So we have standard, draft, standard, and high. Draft would be if you've got a large data set and you just want to make sure you captured everything, we can process it really rapidly.
Let's just get something quick and dirty to make sure that we don't have any holes.
Yep.
There's not any glaring issues or anything like that, right?
That's right. That's like a field check. You go through to make sure everything's good. So point cloud density. We have a number of different density settings: low, standard, and high. For a lot of our mining customers, they like the, as you were telling me earlier today, these point cloud data sets can get huge.
Massive, yes.
Exactly. So when you're doing something like, topo mapping, just general rough surface mapping, you can actually dial this density down and still get a pretty detailed surface.
Yeah, that's what we've found is, we've done some fairly large data sets, and, when you're dealing with 300 and something million points, it gets tough.
Absolutely.
So having that ability to be like, well, do we have to go to 100%? Can we? Sometimes 40% is perfectly fine.
That's right.
To do what you need to do, at least at the moment.
100%. So, like I said, we select our processing quality and density. We can choose a couple of different point cloud file exports. You know, these are not any proprietary file formats. We want to support as many different software systems, you know, that are out there to sort of receive this data. And then we select our, you know, our different deliverables, 3D mesh, as I mentioned, orthomosaic. We also have a point cloud object removal algorithm running on the Edge1. So, for example, you know, this would be used in a cut and fill situation. Maybe you have some equipment in your scan area, and you don't want to count that equipment as a volume change, you know, in your scan area from, let's say, you know,
like, well, this truck moved from here to here, and now this truck came in, and suddenly that's a volume change.
Exactly, not relevant to the important KPIs that the mine has around, you know, tons moved per shift, right? That would be something that really makes a mine hum. We can also create DSMs and DTMs here, and this is actually kind of interesting. What these do is they allow you to create a base map for your drone flight plan. So if you have a very steep surface in your mine, let's say, what you can do is do an initial scan of the area and create basically a 3D surface, a sort of quick and dirty 3D surface that we then export from Edge1 into our flight planner. The flight planner uses that data that you just created, and you're using today's data as the background for your
future data sets,
for your map.
In basic terms, it's like, well, instead of relying on Google Maps for my area, which is top down in pretty much any circumstance,
right?
And if you've seen the 3D view, you know it leaves a little bit to be desired. Not enough for us to be able to do something effective and base a aircraft operation off of.
100%.
I mean, even in that 3D space. So you're able to create that, and you're working off your own map as opposed to something that was generated previously. Could be years.
That's right.
Previously, right? And then, but that's, you know, you're getting a look at the terrain and all that kind of stuff. You can take that into account during your next flight.
Yeah, exactly. You know, our customers are in the business of changing the environment, right? Whether it's, you know, building a building that wasn't there before, or, you know, excavating a hillside and extracting resources. You know, if they're doing their job right, the base map isn't going to be, you know, what's actually in the field there. So this gives you a way to, you know, create a basis for extremely safe and accurate flight planning, right?
Gotcha.
So those are some of the deliverables that we can create. And so I'll just click Start Processing here. Cool. This will process in the background. As I said, depending on which you know, deliverables you create, you know, if you want to add.
What did you select? Right.
Yeah, exactly. So this will probably, you know, complete as we're talking right here. You know, the one that we had kind of just some pretty basic deliverables like a point cloud, you know, that took 3 minutes, right? So here we've got, you know, a whole lot of stuff that we've generated. And while this is processing, we can actually go, let's say, to our next flight area. We'll set this down either over a survey point, or it will get a corrected base position, and then we can begin our next flight. So you can actually do this in series, right? And just, you know, process, fly. The jobs get queued up on the Edge1 in the background. And like I said, you know, for a typical large mine, which is the, you know, average user of a system like this, you know, that data will be done by the time the surveyor gets back to the office.
Cool. Well, hey, we're kind of doing this real time here. So let's talk about our next piece, and maybe we'll loop back and see what our result is. So, I mean, just again, looping back is, you know, the benefits. We've discussed these a little bit, but let's reiterate, you know, the benefits of this over some of the other solutions that are available today. That's a similar thing.
Yeah, sure.
I mean, we talked about this earlier, which is it's faster. It's safer because we have better bases, that kind of stuff, and repeatable.
Right.
Right?
Yeah, exactly. Yeah, I think when we look at the pain points that customers have around, you know, creating drone data, you know, it can be very, you know, it can be very unreliable. We make it more repeatable. They need to spend time in the mining area, either, you know, setting up a base station or setting checkpoints. You know, we eliminate that entirely. And then, of course, faster. Like I said, you know, because we're using this device in the field, we get a laser scan-like workflow. Where, you know, you're not uploading to the internet, you're not bringing the data onto your desktop. What you're doing is you're processing right in the field, right? So, you know, that's something that you know, mining companies care a great deal about. You know, getting results, turning results right around. You know, in the same shift. That's something that we hear a lot. Is, you know, surveyors go out and the operations team wants, you know, their analytic delivered in the same shift. You know,
how much do we have in that pile at the moment?
Exactly.
That's stuff that's, I mean, obviously absolutely relevant to, we're operating today.
Of course.
I need to know what's there today.
And they're doing that 24/7, right? I mean, these are not companies that shut down for spring break or something like that, right? Safety is really big for us. Of course, mining is what they say about robots, right? Are they excel at the sort of dull, dirty, and dangerous jobs, right? We see more and more mining companies migrating towards autonomous systems,
right?
And this
take a lot of forms.
Exactly right. It could be in the air, on the ground, underground, and I know you guys do just about everything in that realm. But for example, this is a system that allows surveyors to stay out of the mining area and really just stay. These autonomous trucks can be driving into a digging area, being loaded by a large shovel, and in the past. When they've used maybe truck-mounted laser scanners, right? That's actually a typical kind of
application.
That we're targeting, right? That's the typical tool that's being used to do this kind of work today. Is say a laser scan, expensive laser scanner mounted on top of a truck.
Right.
The surveyor will drive into the mining area, stop and basically complete a scan. Now that surveyor is no longer driving into the mining area, right? They're removed from a safe distance and they can just fly over the whole operation.
Right.
And then, on just that last thing on repeatability, we want to be as repeatable as a laser scanner. We control the whole process, like I said, from end to end, right? Capture, process, analyze.
It's. I mean, again, I think many of our users have experienced this. Now I'm going from using this to capture stuff, and now I have to take it from here, and I have to go take it to this other party, and then it goes from this party to this party, and it just gets messy.
Yeah, of course. This is far fewer software systems that can be replaced. And again, I think if you want to check out our website, we actually have a time and use study that we did with a large mining customer. And on a typical day of, say, collecting maybe 3 to 4 data sets of around 40 acres each, we're saving total time about an hour and a half. And where the surveyors, the users, the pilots, they used to have to learn 3 or 4 different software systems. We're doing that in one place with the Skycatch Edge1 and then a DJI drone.
Right. And again, that's another one of those benefits is, like we've talked about, is on-site processing. It's
100%.
happening there.
Yep.
So and I'm me personally, and I think most people, is it's fewer cogs in the machine. Simplicity, simple is always best. Keep it simple, stupid, right? It makes everything go smoother. It makes the operation better. It echoes across the entire operation. It makes your whole life easier to do something like that.
Yep, and and I would just add, in addition to this, we have some downstream tools. So we have an entire sort of online program that we call Data Hub. We also do cloud processing. So if you're something like let's say a civil highway builder, and you're not operating in a very remote area, or you're not touching data that's very sensitive and can't be put on the internet, we have you can upload data sets of thousands of photos uploaded to our cloud. We'll process those, create just as many deliverables as we do here on the Edge1, and there's an entire suite of analytics that we run on Data Hub that allow you to both analyze, like I said, and share that data, right? So for some of our maybe construction-focused users, they're seeing the site awareness and sharing, sharing of a comprehensive common operating picture between the site owner and each subcontractor on the site. Everyone's looking at the same data. They're logging into Skycatch.
Working off the same place. It's a level playing field, maybe.
Yeah, exactly.
Everyone's working off the same thing.
That's right.
We're using the same map. We're working off the same plan.
Exactly. It's and I think of whether it's a mine, whether a construction site. When I think of people using Skycatch 3D data, I picture generals sitting around a sort of a battle plan, right? Everyone sees exactly what's going on.
A fancy risk table.
Sure, right? Or Dungeons and Dragons or something like that. Warhammer. They can, everybody sees what happened. The data is fresh. There's no questions about the situation, and of course, again, everything's measurable, right?
Right.
I would say that's a big difference in industries that are, there's lots of industries I'm sure you've seen that use drones for maybe video capture and inspection. Those are qualitative measures. once you start 3D modeling, you're bringing something into the quantitative zone, right? So
we can assign a number to something.
exactly.
And make it actionable.
That's right. And I think that's kind of the core value that we have is, we create, we provide a system that takes, things that were very hard to quantify in the past, and quantify them, very reliably, very repeatably, and very precisely.
Right. In an easy to use format.
That's right.
So I think our data is probably done.
Cool.
Let's take a look at it.
Yeah, let's take a look. So the processing settings that I chose, standard processing quality and normal point cloud density, right? So again, for that kind of topo surface mapping, that's really what our users like. And the accuracy I would expect on this, let's say I'm flying an M300 at something like 300 feet or 100 meters, we're going to see around 5 centimeters or just shy of a couple of inches of vertical accuracy. We can tie that in even more. We can fly a little bit lower and get that really down to nice survey grade accuracy. For the outputs that we have, we chose point cloud, 3D mesh, orthomosaic, DTM, DSM, and our base maps for flight planning, right?
Yeah, so basically a little bit of everything.
Absolutely. We turned everything on, and I mean, these are as many deliverables as you might want, to address, all of your users, right? It could be operations, they're accepting the point cloud. You could have, someone using the mesh to, render a video, orthomosaic, right? You can export that as PDF, things like that. So really supporting a number of different use cases, basically downstream of this Edge1, right? We can preview these right here. I'll just click that. And this will load the point cloud. We looked at this earlier. That was sort of like a draft quality, and here we're seeing we have a nice, nice dense, more dense point cloud, right? So we can see all the detail and sort of the buildings that we captured there. So dense point cloud.
And you're talking, 50 photos.
Yeah, that's right. So this is a small capture area. I think we'd go up to say 500 photos, right, and cover a bigger area.
What I was getting at is look at what you grabbed. And look at what the result is from 50 photos.
That's right. Yeah. So
that's all it took to pull this off.
Good size area. We ran this on a on our standard processing settings with all the deliverables, and this took, as you can see, 10.5 minutes. Right. So that's really, I think, what makes the Edge1 special. We take a number of different pieces of software. We basically cram it all inside of a GPS base station.
A very attractive little box.
Thank you. Yeah, this is I think very, very distinctive for Skycatch. Reflective of our logo on top. But this has been used for years by surveyors in the field. Replacing laser scanning, safer and actually cheaper. When you look at the sort of operating cost of this over the course of a number of years.
I mean, your ROI is more or less no-brainer at that point.
Absolutely.
Sure. Well, cool. I think we're just about wrapping up on time. So again, for more information on Skycatch, obviously there's Skycatch's website. There's
Skycatch.com.
A plethora of videos, but also contact us at RMUS if there's something you're looking at putting into your workflow. Give us a call. You're going to talk to our sales guys. We'll make sure we get all those questions answered for you. But this isn't the last that you're going to hear from Skycatch. We definitely are going to revisit this, have more examples and more videos. But hopefully that gave you a good introduction to it. And stay tuned for the rest of the content that we have. So thanks again for coming, and we'll see you guys next time.
Yeah. Thank you.